reason why we use this wavelength. This is one very important reason. Actually, when you expose the top of the skull, this is the helmet in front of me here, I'll show you in a minute a bit more. This light wavelength actually penetrates through the skull into the brain quite deeply. You're talking about that sort of length. It's quite surprising, maybe. You think, how the heck does that work? In fact, the skull works as a lens. It actually focuses the light. I didn't know that when I first studied this wavelength. I was pretty rubbish at physics at school. I didn't really understand that principle. I assumed, okay, you had to design the light to go into the thinnest parts of the skull, but in fact, it's the complete opposite. The skull was actually focusing the brain deep into the skull, into the brain. The other aspect of this wavelength, it is actually the peak transmission wavelength of water. And as your brain, 70% of your brain is water, so once it's in, it actually penetrates even deeper because it goes through water very well, or travels through water. Okay, so that's a very good reason to look at this wavelength, okay, to start with, because it needs to get in to the target. Okay, so for me as a pharmacologist, understanding that, yeah, it has to get to target, otherwise it's not going to do anything. So that's the first thing, okay? So that's, right, so we're going back to Alzheimer's disease, just to take you through a little bit of what it's about. It's a little bit depressing, some of these slides, obviously, because it's a tough disease, really tricky disease. And there's lots of different processes. As I said, it's a complex disease. Lots of things happen over time as the disease progresses. Things like inflammation, you lose the neurons, the connections, they're called synapses, the connections, you lose them, and you develop proteins that you probably have heard of, things like amyloid. You may have heard amyloid protein. When you look at an Alzheimer brain, you see these deposits of protein. That's when proteins have been misfolded, chucked out, and you get these plaques. In fact, it's a bit of a red herring. It's too late then, actually, in the disease progression. Okay, but anyway, it's a very important part of the disease pathology. Okay, so just bear that in mind. Okay, I'm going to tell you a little bit about what happens in aging. You know, when you get to my age, things are starting to go a bit awry. So things like reduced battery function. So what I mean by that is in the cell, you've got an organelle called a mitochondria, and that's your battery, basically, that runs the cell. Okay? And as you age, that starts to get, starts to drain a bit, get lower and lower in terms of activity. Okay? Also, as you age, you start to lose neurons. Cells become stressed, different ways of stress. Physiologically stress, behavioral stress can cause cells to be lost for various reasons. Okay, so in an Alzheimer brain here, you can really get a real loss of nerve cells. Okay, so bear that in mind. And within that, you've got the protein, all these horrible proteins misfolding and things like that, and that kills neurons. Other things, you get misconnections. Connections start to go awry. That's what this image is supposed to depict. You're starting to lose connections between neurons. And finally, as I said, inflammation is a really important aspect of brain disease. Parkinson's, Alzheimer's, all the ALS, all those, inflammation is a massive problem. And it's quite often because as you age, as I said, your blood-brain barrier, that barrier that helps you protect yourself from excessive inflammation, starts to get a bit leaky, and things start to get into the brain and start to affect the brain. Okay, so inflammation is a really important facet of Alzheimer's disease. Okay, so what does the light give you? Okay, bearing in mind those complex elements that underlie the disease, and if you really want a game changer in terms of treating the disease, you need to affect all those processes simultaneously. Okay, so the first thing this treatment does, this light, and actually other wavelengths of infrared light do similar things, okay, is do this. So it produces a gas, nitric oxide, not laughing gas, similar. I often get asked that, is it laughing gas? No, it's nitrous oxide, it's slightly different. But nitric oxide is a really important gas, physiological gas, and one of its main functions is to dilate your blood vessels. So in other words, it makes them expand and more blood can flow into your brain. Okay? Again, doesn't take too much to think about that. That's a good thing, yeah? When you have Alzheimer's disease or other diseases, your blood supply starts to get a bit ropey. Blood supply, more energy potential within the cell. So you get images like this, increased blood flow. the red indicating more. Okay, so that's what this therapy does. And that was actually the first thing our first paper actually demonstrated that it did that, and it did it quite selectively for that wavelength, more than the other wavelengths. Some wavelengths weren't so good, actually they went the other way, so we've avoided those over the years. Okay, so it's not all good news with light, generally. Okay, so other things. So it does that, which is great, but it's not all about that. Other things it does, it increases the energy. So this is your battery. In every new nerve cell you've got, every cell in your body actually, pretty much has mitochondria. It's your batteries that run all these cells. In the brain, you need a lot of mitochondria because the brain is pretty active. In fact, 30 or 40% of your oxygen supplies goes to the brain, really. The rest is for the rest of the body. So it's really important to have that and have a battery that's working well. So you get increased ATP, which for those, who are up on your biology, that's your energy source. ATP is what you're trying to generate. As well as that, this is the image to depict, you're starting to recharge your battery. So you plug in your charger for your battery, it's starting to recharge it. Okay, so we've got, biological evidence for this. This is just obviously a pictorial representation of what's happening. Other things. So other things is that you also increase particular proteins, like this protein is a neurotrophic factor, so it's a nerve growth factor. So that tells you what it does. Okay, so in other words, it potentially can repair or regenerate neurons, which again is a good thing for brain diseases, potentially, for recovery and repair. So it does that. And finally, on this side, I've depicted it with this little schematic, chaperones. Chaperones are like friendly proteins that you can stimulate with this light therapy. And we've shown a lot of these HSP40, HSP70, very important stress-induced, because I class the light as mild stress, and a little bit of stress is good. Okay, it induces these protective responses. And that's what these chaperone proteins are. They're very important stress responses and very important protective chaperone proteins. That's why they're called chaperones. They help people and look after people and support, in this case, support cells, support neurons. And the other thing they do, they also reduce the amount of this protein aggregation type phenomena. Okay, and that's shown on this slide, which is when I saw this data and a student showed it to me first time. This is in an Alzheimer model, a mouse model of Alzheimer's, because only humans actually have Alzheimer's, no other species on Earth. So we do have to sort of make a mouse out, give them Alzheimer's to be able to study them, to develop therapies. So that's an interesting, you may not be aware of. So here, hopefully you can see, this is before and this is after treatment. You can see the staining levels have dropped generally, which is that's the stuff we need to actually target, not these plaques, because that's a bit of a, like I said, it's the end of the process. It's a bit of a red herring, but in fact it does reduce the plaques as well. But the important thing, it reduces this amyloid protein quite dramatically. Like I said, I nearly fell off my seat when I saw the result of this, okay? Anyway, so it's doing all the things you want it to do. It ticks all the boxes that I talked about. Okay, the proof in the pudding. So this is introducing Gordon, who's the very tall South African GP from Peterlee that knocked on my door, who I met this morning to pick up this, to show you all. And this is Abdul, my slightly grumpy behavioural. He doesn't like his photo taken. In fact, he didn't want his photo taken for this latest press release we had. He said, no way, no way. He's very modest, he's an incredibly bright guy, but he's very modest. You can see how grumpy he was for this photo. Anyway, so this was our sort of, as it was described, Star Wars helmet, the prototype back in 2008. Okay, and this is our first guinea pig. Anybody recognise? The older members of the audience will recognise. This is Terry Pratchett, famous Discworld author. He was our first guinea pig because he contacted us, heard about our research, and tried it for the rest. Actually, he had very severe dementia, the very, very quick-acting dementia, and he used our helmet throughout the period, and he actually managed to write 4 bestsellers after he started. I'm not saying that's N equals 1, obviously, but, I'm not saying we made a difference, but it certainly, he was very happy to use it. So that's our first. So this is the prototype now. at least the UK version. There's an American version that's a bit more snazzy. But this is actually the version that was used in our recent clinical trial for Alzheimer's patients that I'm going to show you the data from. This young lady, she'd like me to say that, this is one of our candidates for our aging study. She doesn't have dementia, but she used it in an aging study, and we showed improved memory and sleep, even in middle-aged individuals like myself. Okay, and that was just an 8 to 12 week. So the strategy, you use this twice a day, 6 minutes, press the button, 6 minutes, delivers the light for 8 or 12 weeks in our studies so far, okay? You don't really need to understand this, but this is, you can look at the physiology of the brain and the effects. So I've put the arrow here. So, for example, here in this delta pulse, this is the oscillations, the physiology that's happening in your brains as you listen to me, hopefully. Yeah, these things, and hopefully you'll remember what I'm saying because of the action of these oscillations, okay? So you can see here, in this case, you've gone from a very cold, low activity to a boost in activity in that particular oscillation. And similarly, got other things here. We've gone reduction in activity. This is, you don't need to know, like I said, delta coherent reduced. That's a sign of improved attention and memory. Okay? That indicates, okay, it's doing something physiological. This is what it's doing behaviorally, which is the most important thing for you guys to see. So this is an example of a test. An Alzheimer's patient, a mild to moderate Alzheimer's patient, would have difficulty drawing a clock. You might think that's a simple thing, but actually when you have Alzheimer's, this is the sort of thing that's difficult to do. So this is before and after. I don't really need to show you describe the difference. You can see it for yourself. So it's an individual only 5 weeks treatment resulted in that sort of a improvement. Okay, the other thing I'm going to show you in terms of data is a very commonly used memory score, the so-called mini-mental score, which is a classic sort of memory test for a range of memories. And this is the sort of graph that depicts what happens. So most of the guys, hopefully in the audience, are up here in the 30 to 25. I'm probably in the 25 and dropping, being a little bit older. Yeah, so you go from sort of early diagnosis, 25, so the scale is 25 to 0. Okay, I mean 0 is obviously the end, but so you got mild to moderate and then severe down here. So the drop-in number indicates the reduction in memory performance. Okay, so this is again a fall off the seat moment when my colleagues in America, because this trial was done in the US, UK didn't want to know. US did it, FDA approved. Okay, so these 2 arrows are just to show you the things to focus on. So this is ladies and gentlemen. Okay, that's very important. It works equally well, which is unusual for a lot of treatments and therapies. Okay, you can see very easily by eye a highly significant increase. So in other words, you're improving your memory performance, and it's nearly 5. Okay, an increase of 5 MMSE on a 25 scale. It's like taking somebody from mild to moderate Alzheimer's back into more just middle age levels of memory, okay? And that's 8 weeks of a 6 minutes treatment, okay? A remarkable effect. I have to emphasize this is in a small group, relative, about 100 patients, okay? So it's a relatively small pilot study, but highly promising, obviously, for obvious reasons. And the other important thing to bear in mind, no side effects. 0. I've tried very hard because like I said, I'm a skeptical academic. I need to find side effects because there's no such thing as no side effects in any drug treatments or anything we do. Zilch, zippo.